So I wanted to build off of the last video with a real-world example of point-to-point networking and how you can use it to ping one machine to another machine or transfer files from one machine to another machine without the use of a router or DHCP. So for these examples, I have two identical Windows 10 virtual machines, and the way that they're set up in terms of their networking is like this. So it's similar to the last video in that we have two machines that are attached to the same switch, but without any kind of router or any way to the internet or anything like that. They're basically, these two virtual machines are inside of their own bubble. So what I'll do first is I'll open up the command prompt window on both of these machines here. And on both of these, I will type in ipconfig to show what the current IP address is for both of these. So there is no DHCP server and there is no static IP address set, but you can see that they both have IP addresses. And the reason they have IP addresses is that a lot of machines, Windows machines especially, are designed so that if they are not able to reach a DHCP server, they are able to give themselves an IP address so they can talk to other machines that also can't reach a DHCP server. So if I go back to my packet tracer example, for instance, the same scenario we have here, if I go to my computer here and request a DHCP address knowing that there's no DHCP server for it to talk to, it will fail. And it will instead give itself an IP address that's very similar to what Windows has given itself over here. And by doing this, it allows the machines to be able to talk directly to each other without needing a static IP address set. So I can do the same thing to this machine. Request an IP address. Again, it failed, and it gave itself a IP address that it can use to now talk to this other computer here. So to prove the point that both of these machines can talk to each other, what I can do is go back to my Windows computers, and since I know what the other IP address for this machine is, I can go to my first computer here and type in ping and then this computer's IP address that it's given itself. So 169.254.203.246. And you can see that it's able to ping from one machine to the other. And the same is true in reverse. If I do 169. You can see that these computers are not able to send packets back and forth to each other. So there's a couple more commands you can run that further illustrates that these computers are able to talk to each other. First, I'm going to clear both of these windows. And on this computer, I'm going to type in arp-a. And on the other computer, I'll do the same thing. So you can see on here, there are two entries in here, one of which is the computer's own IP address, and the other is the other computer's IP address. If I go and type ipconfig again, oops, you can see that this computer, for example, has the 97.253 address. And if I go over here, in this computer, you can see it has a dynamic entry in its ARP table for that computer. Another interesting tidbit about this dynamic IP addressing system is you can also ping the host name of the computer. So if I type in host name on the command line, oops. So I type it in for both machines. You can see this computer is called desktop 1, this one's called desktop 2. And the host name is just basically the name of that particular machine. So what I can do now, and I'll capture this in Wireshark, is I will type ping desktop 2. I'm pinging desktop 2 from desktop 1. Hit enter, and you can see the packets are going through. I go to Wireshark. You can see here that it's first asking ARP packet, where is this machine? and then it's sending the ping requests. So now I'm going to set a static IP address for both of these machines instead of using this dynamic IP address. To do that, you want to get to the networking control center. The fastest way to get to it is just to press the start menu and then type in network connections. And you'll see one up here, view network connections. Click on that, and that'll take you directly where you need to go. I'll do the same on this one too. There it is. So when you get to it, you'll see a window that looks like this. And in here will be all the adapters that will be on this machine. Right now on these machines, there's only one adapter. And we need to get to this page. There's multiple ways to get to it, but you eventually will end up at this page here. To set a static IP address, you want to go and right-click on the Ethernet or whatever kind of adapter you're using. In this case, we're using Ethernet. Go to Properties. Go down to Internet Protocol version 4. Hit Properties again. And then you want to hit the radio button, use the following IP address. And this is where we would enter in our IP address like we did in Packet Tracer, where we want to enter in a static IP address, subnet mask, and gateway. So for IP address, I'm going to keep it simple, 192.168.0.1. And the network mask will automatically fill in. For this type of network, that's just happens automatically. I'll do the same thing on this machine. Properties, IPv4, IP address 192.168.0.2 instead of 1 this time. And same network mask as before. Hit OK, close on both of these. And now when we go back to our command prompt, you can see that before we had this static IP address, or this, dynamic IP address. But if we type in ipconfig again on these machines, now they each have that static IP address that we assigned earlier. So while we're on the subject of setting static IP addresses, this might be a good time to show you what can happen when two machines have the same IP address. If you remember back in the last video, what happened is one machine notified the other that it changed its IP address, and it rejected it immediately. And it was pretty clear. It told you in the window here why it was rejected, and it basically just said that there was a duplicate IP address. I'm going to do the same thing in Windows, and Windows can be a bit strange about it with how it notifies you about it. It may notify you with a pop-up that there is a IP address conflict, or it may not do anything at all. So let's see what happens this time. I have a couple of things running right now. So I have Wireshark running right now. We can ignore this. What I'm going to do is I'm going to firstly clear the ARP cache on both of these machines. And now I'm going to, that basically just, what that does is it removes all the entries to, all the network entries that it knows it removes from its lookup table. So if it did have a route to this machine, it just deleted it. So I'm going to go back to my network settings. I'm going to go to Properties. I'm going to go to IPv4, and I'm going to set this to 1, which is the same IP address as this machine here. Hit OK and close. And you can see nothing really happened. If I go to ipconfig on both of these machines, you can see this one still has 192.168.0.1 like it's supposed to. This one has gone back to using that dynamic IP address that it had before, even though we've specifically stated that it's to use that one IP address, the IP address that's the same as this computer. If we go to status on this machine and go to details, you can see this is what it's supposed to have, and this is what it actually does have. But you can see it didn't really say anything about that. It didn't tell you, it didn't pop up with a message. If I go to the notification center, nothing really that's related to this is coming up. Windows XP, for example, back in the day would have a pop-up window that appeared right about here that said there was a conflict detected in the network. But It doesn't always work that way with Windows, unfortunately. But there's several ways you can see if there was an issue with an IP address conflict. So one of them, probably the first one I would try, is we just did ipconfig, and you can see that it's no longer using the IP address that we want it to. It's not even close. So that should be a clue right away that it's not accepting the network settings. Another you can do is go into Event Viewer. So if I refresh this, actually I just cleared that one, so let's go to the other machine. So this machine here, the one we just put up, I'll go to Start and type in Event, and the first one's going to be Event Viewer. This might take a second to come up. We've got to go to Windows Logs and then System. And this is basically like this is the system log for the machine. If something happens that's a bit odd, it will show up in Event Viewer as a error or an exception. So now the records have come up. You can see in here, the very first one at the top is an error for TCP/IP. And down here in the details, you can see here, the system has detected an address conflict for IP address 192.168.0.1. So it's basically saying that this is the equivalent of packet tracer. Its window appears saying that there was a duplicate IP address detected on the network. And one thing you might think is, well, what about the diagnostics thing, Windows diagnostics? If I hit, for example, if I right click on Ethernet and click diagnose, maybe we'll come up with some kind of answer for this problem. So we can let that run for a second, but I don't think it's really going to find anything. And there you go. Couldn't identify the problem. So unfortunately, some of the systems in Windows are not as smart as they should be. It didn't detect that error, even though in the event viewer, we clearly see that there is a IP address conflict. To delve even deeper into this, we can look at Wireshark. And when I set this up originally, I had Wireshark recording all of the network traffic from when we changed the IP address to be the same as this computer here. But all we really need, even though it captured a lot of stuff, the only ones we really need to care about are for the first 5 or 6 packets or so, but about to there. Actually, no, about there. These packets right here are the ones that actually matter. The rest of this is just other stuff. So once we hit close on the configuration window, that signals to Windows that it's to change its IP address to whatever we want it to be. So I'm sorry, if we hit OK. If we close this, once we hit OK on this window, that's what triggers Windows to change its IP address. And that's what starts this process here. So what it did first is this machine sent out an ARP request trying to figure out who has the IP address 192.168.0.1. And if you remember from Packet Tracer, ARP requests are sent to every device on the network, or every device that it can reach realistically. And the way its logic is set up, it's expecting there to be no response. If it sends out an ARP request and it doesn't get a response, it'll know that, okay, no one's probably using this IP address right now. But you can see here, the next packet comes from our computer here saying that I have the IP address. And we can tell that because the MAC address of this computer matches this computer. And we can check that by typing ipconfig/all. We have here the physical address, which is a serial number that is burned into every network adapter, and it's unique for every device on the market. So for this particular machine, its Ethernet adapter has this burned in address. So we can just ignore most of it and just focus on, it says 8961. That's what we want to look for. So this one has the physical address 8961. We can see over here, this machine is responding that it has this IP address, and it ends in 8961. So this machine sent this packet to our machine over here saying that I already have this IP address. And that's when Windows sets its dynamic IP address. You can see here the 169.254. That's Windows dynamic IP addressing system that we saw at the beginning of the video. And it does the same thing. It sends who has this IP address, sends it to everybody, and you can see it does that a couple times. It doesn't receive a response, and then it sends out another ARP request saying that, okay, now I have this IP address. And if I go into the, well, actually, it's not going to show on this computer because it's on a different network, but if there were other machines that were using the dynamic IP addressing system, they would get this message and say, okay, this person has this IP address now. But that might sound very complicated, and frankly, it kind of is. But the main idea is that the processes that happened in Wireshark here in the last video are also happening with this. It's done a little bit differently in terms of its order of operations, but the end result is the same. It's detected there's an IP address conflict, and it's rejected trying to use that address. Here I have the same setup as before, but instead of using Windows 10 computers, now I'm using Windows XP computers. But you can see here that I still have the same network setup. So this is 192.168.0.1, and this is the same but uses .2. And what we want to do in this is, same as before, I'm going to change this computer to have the same IP address as this computer here. Change that to 1. And you can see immediately both computers have come up saying that there has been an IP address conflict. This one down here, there is an IP address conflict with another system on this network. And this message here is saying that the static IP that was just configured is already in use on the network. So it just kind of goes to show how inconsistent Windows can be with alerting you to problems with the addressing. So you can see here this maintained its IP address, but this did not give itself a dynamic IP address. And finally, just for fun, we can look and see what happens with a Mac in the same scenario. So I have my Windows 10 computer, 192.168.0.1. Same configuration as before, just instead of having the second Windows computer, I've replaced it with a Mac. It's still hooked up the same way. So if I go to System Preferences, you can see here it's trying to use DHCP, but it's not able to reach it, just the same as Windows computer. So it set itself a self-assigned IP address, same as Windows did initially, in the 169.254 range. So that happens on multiple platforms. It's not just for Windows. But for now, let's go ahead and give it a manual IP address. That's the same as the first computer. And make sure the subnet mask is also the same. So now we hit apply. You can see here there's a message that pops up that says that another device in the network is already using that IP address. So now what I'll do is I will set this back to the IP address it had before, make it .2. Okay, and close. And I will do a clear and then ipconfig/all. And you can see here that it now has the IP address it's supposed to with its network mask. You can also see here that the physical address is different from this physical address, and that's how the two machines on a certain layer of the networking are able to differentiate each other. So now same thing as we did before. I'm going to ping our PC over here from this machine here. So I'm going to do ping 192.168.0.2. And you can see the packets are going through just fine. If you do have an issue with this, what you need to do is turn off the Windows Firewall. For this example, you need to turn off the Windows Firewall, especially when we get into the stuff that we're going to do later. we'll need to have those restrictions lifted, even though it's not the best practice to do it. But just for this example, just turn off the firewall. And same as before, we can also do ping desktop 2, ping the host name. Can do that on both machines, and it also works. And the reason this works is a bit beyond the scope of this video, but it's able to associate the host name of a computer with an IP address on its own. It doesn't necessarily need to have a DHCP server to do that. So now I'd like to do something a bit more on the graphical side. I'm going to set up a folder on this computer that's going to be accessible by this computer over the network. So first thing I'm going to do is I'm going to go to the desktop and make a new folder, call it share. Now, to get a shared folder working, it takes a little bit of, there's some steps involved with doing that. So if you're not interested in that, you can scoot forward a bit, but I'm going to go through them and make it so that this folder is accessible by this computer. So first things first, I'm going to right click on the folder, go to properties, go up to sharing, go to advanced sharing, click share this folder, and go to permissions. Click on that. Everyone is already in here, and that's what we want. I'm going to go to this and select full control for allow. Hit apply. Okay. Hit apply again. Okay again. Now you want to go to the security tab. I'm going to go to edit. I'm going to add. I'm going to add the everyone object. Hit check names, and that'll complete to this right here. It'll be a little underline underneath of it. Click OK. And then for everyone, click on that, and then hit full control under allow. Hit apply. Hit OK. And then you can close out of that, and this folder is now ready to be shared, but there's still one more step we need to do. In here, because this is an unrecognized network, we need to go into the sharing network and sharing center. Now we want to change the advanced sharing settings. And for this, I'm going to go to all networks. I'm going to turn on sharing for everyone. I'm going to turn off password protected sharing. I'll click save changes. And this is really just for this particular example, but now at this point, this folder should be accessible from this computer. And before I do that, I'm going to go into this folder and make just a text file. So from this computer, now what I can do is go open up the file manager, and I'm going to type in 2 backslashes and then the IP address of this computer here. So 192.168.0.1. And you can see here I have 2 folders, one for users and one for share. Share is the one we want, that's the one we just made. Click on that, and there is our folder. And it's able to remotely access this file through the network. So I can click on this, add some text to it, I'll save it, close it. If I go back here, open this up, it's now changed the contents of this file. One other note is that if you're having trouble connecting these machines together, it could also be the firewall. If you go to the Windows start menu down here, just type in fire, check firewall status. What I've done for this is on both of these machines, I've disabled the firewall by going to turn Windows Firewall on or off, and just turning both of these to off. This is again really just for this particular video. You shouldn't probably have the firewall off unless there's a specific reason to have it off. The better idea would be to add a rule that would allow the remote file sharing through the firewall. But again, just to keep it simple, just turning off the firewall entirely. So hopefully that it gives you a better idea of what's happening in the previous video, but on real computers. You could do this yourself. If you're in the BMET lab, for example, if you have two computers, you could take a network cable and plug one computer. You could take a single Ethernet cable and plug two computers into each side, and follow these exact same steps, and you'll get the same results. I just did this in a virtual machine because it's easier to get both windows on the same screen.